In this video, we write a C program to print a Fibonacci series up to given value. This is the Fibonacci series. Already we have seen in the last video. The Fibonacci series, it starts with 0 and 1 values, and the next value is obtained by adding previous two values 0 plus 1, 1. Then next value is obtained by adding previous two values 1 plus 1, 2. In this fashion, the Fibonacci series continues. In the last video, we have printed Fibonacci series for given number of terms, but this program is different. Here we want to print Fibonacci series up to a given value. Now see this example. If we give n value 0, then it prints 0. If we give n value 1, then it prints the entire series up to 1, that is 0, 1, 1. If we give n value 2, then it will print the entire Fibonacci series up to 2 value. And if we give n value 10, then it is printing up to 8. Why? Because what is the next value? 5 plus 8. What is the next value? 5 plus 8, 13. But it is beyond the limit of 10. That's why it is not printed. So in this fashion, we print all the Fibonacci series up to the given value. Now coming to the program, here we have taken a Fibonacci function which is taking only 3 arguments and it is not returning any value, and the 3 arguments are of type integer. In the main function, we are reading n value and then we are checking if n value is equal to 0, then we are directly printing 0 value. Otherwise, we are printing 0 and 1 directly, and then we are calling Fibonacci function by passing arguments 0, 1 and n value. So the Fibonacci function is starting with values 0, 1 and given n value. Now you see the Fibonacci function part, it is calculating a plus b value in C, and then it is checking if the added value, if the C value is less than or is equal to given n value, then it is printing C value, and again it is calling Fibonacci function by passing b, c and n values. That means again it is calling the same function. That means it is making recursive function calls. In this fashion, this particular Fibonacci function will work. And then we see the logic here. We see the background analysis. Let us say we will give n value 3. Now 3 is not is equal to 0. Now this condition is failed. We come to else part. In the else part, we are directly printing 0 and 1. Then what will be the output here? We are directly printing 0 and 1. Then we are calling Fibonacci function by passing values 0, 1 and n. Now here a value becomes 0, b value becomes 1. Now what is n value here? N value is 3. Then in this Fibonacci copy function, C is calculated. What is C value here? A plus b. A plus b value means 0 plus 1, that is 1. Again we are checking C is less than or is equal to n. That means 1 is less than or is equal to 3. This condition is true. Then we are printing C value. What is C value here? 1. So we are printing C value. And again we are calling Fibonacci function with values BCN. What is B value? 1. What is C value? 1. What is N value? 3. Then it is calling again Fibonacci function. Here values are A value becomes 1, B value becomes 1 and N value becomes 3. Again another copy of Fibonacci function is created and it will be placed in the stack. Here again we calculate C value A plus B, 1 plus 1, that is 2. Again C value is less than or is equal to n. If we compare, 2 is less than or is equal to 3. Again this condition is true. Then we print C value. 2 value is printed. And then again it is calling Fibonacci function with values B value. What is B value here? 1. What is C value? 2. Now n value is 3. Again it is calling Fibonacci function. Here A value becomes 1, B value becomes 2 and n value becomes 3. Now C value a plus b, 1 plus 2, that is 3. Again 3 is less than or is equal to 3, which is correct. We print C value, that is 3. Again it is calling Fibonacci function with values b value 2 and C value 3 and n value 3. Again another Fibonacci function is called here. In this function a value is 2, b value is 3 and n value is also 3. Then we are calculating C. C is equal to a plus b, that is 2 plus 3, 5. Here this condition is failed. Why? Because 5 is not less than or is equal to 3. That means now these statements are not, they are not executed. That means now this recursion process is stopped at this point of time. Now there will be no more recursive function calls, and as there are no more statements here, the control is returned to its caller. Again here also there are no more statements to be executed. Again control is returned to its caller. Again here also there are no more statements to be executed. Control is returned to its caller, and similarly here also there are no more statements to be executed. Again control returns to the main function, and in the main function also there are no more statements to be executed. Again the program will be stopped. In this fashion this particular program will work. Now we see the stack involvement here. Initially main function is called, let us say we have given n value 5. As n value is not is equal to 0, it is printing values 0 and 1. That means it will print values output. First of all, and then it is calling fib of 015 function, and fib of 015 it will call fib of 115, and similarly so on. The functions are placed in the stack here as they are called. Now we see initially let us assume that in the main function we have given n value 5. As 5 is not is equal to 0, it prints 0 and 1. So in the output we get 0 and 1, and then it is calling fib function with values a comma b comma n. That means 0 comma 1 comma 5. In this function a value is 0, b value is 1 and n value is 5. Then C is calculated, a plus b, 0 plus 1, 1. And then we are checking condition. C is less than or is equal to n and 1 is less than or is equal to 5, which is correct. Then we are printing C value, that is 1. Then Fibonacci function is called again with values b comma c comma n. What is b value? 1, c value is 1 and n value is 5. Another copy of Fibonacci function is created and it will be placed in the stack. The arguments in the local variables in this function, they are placed in the stack. They will occupy memory in the stack. Here a value becomes 1, b value 1 and n value is 5. And then C is calculated, a plus b, 1 plus 1, that is 2. As again here C value is less than or is equal to n value, which is correct. 2 is less than or is equal to 5. Again C value is printed, which is 2. And then Fibonacci function is called again with values b value is 1, c value is 2 and n value is 5. Now another copy of function Fibonacci function is created and it will be placed in the stack. Here a value is 1, b value is 2 and n value is 5. And after calculating C value, a plus b, that is 1 plus 2, 3. Again condition here, C value is less than or is equal to 5. 3 value is less than or is equal to 5. So C value is printed, which is 3. And then Fibonacci function is called again with values b first, b value is 2, then C value 3 and then n value 5. Next another copy of Fibonacci function is created with values 2, 3, 5. And then here a value is 2, b value is 3 and n value is 5. And after calculating C value, a plus b, 2 plus 3, 5. Again 5 is less than or is equal to 5, which is correct. Again C value is printed, whose value is 5, and then it is calling Fibonacci function again with values B. B value is 3, C value is 5, and N value is 5. Another copy of Fibonacci function will be placed in the stack, and all of its arguments will occupy memory. Here A value becomes 3 and B value becomes 5, N value is 5, and after calculating C value, A plus B, that is 3 plus 5, 8. Here, when comparing C value with N value, C value is not less than or is equal to 5. That means now there will be no more recursive function calls. At this point of time, recursion is stopped. Then automatically the control returns to its caller. Here also there are no more statements. Then control returns to its caller. Here also there are no more statements to be executed. Control returns to its caller. Here also no more statements. Again control returns to its caller. And similarly, finally control returns to main function. In the main function also there are no more statements. And finally all these functions will be removed from the stack. They are removed from the stack in first out order. First of all, fib of 3, 5, 5, it will be removed from the stack. Then the next function, then next function, and so on. And finally, once main function is also completed, it will be removed from the stack. In this fashion, each and every function will occupy memory in the stack and it will be removed from the stack.